Hi there, and welcome to the Math Applications or MAPP workshop given by Jaguar Tutoring here at JCC. So calculators are helpful tools used for many functions in math and science. To best use these, it's important that you become comfortable with the capabilities of your specific calculator. Today we're going to talk through the basic functions of the TI-30XS and the TI-36X Pro. In this video, we're going to cover a few basic things. First, we'll look at getting to know your calculator and other important functions. And then we'll consider some basic mathematical concepts like scientific notation, fractions, the order of operations, how to manipulate equations, and especially for Math 172, how to convert between degrees and radians on your calculator. Let's start with getting to know your calculator. This calculator is the TI-30XS. This is the TI-36X Pro. You'll see that they look different. They have slightly different functions to them, but they're not too difficult to understand if you'll take some time familiarizing yourself with their workings. The first thing you should look for on your calculator is the number pad and the four basic operations: multiplication with an X, addition with a plus, subtraction, which has a minus sign, and division, which can be done with either a division symbol or a /. To perform a calculations, you'll make the necessary keystrokes and hit enter. For example, on your calculator, key in 4 divided by 2 and hit enter. You should get the answer 2, which is what we expect. Next, try a few small calculations like 2 plus 3 and 4 times 5. Take note of the following. After you hit enter, is the input, the original formula you put in, still showing on the screen? Can you scroll back through previous inputs using arrow keys? The answer to those questions will depend on what type of calculator you have. Please note that most calculators differentiate between the subtraction sign and the negative sign. You'll see on one side of your calculator, here is where your operations buttons are typically located, along the right side going down. There will also be another negative sign, usually down near the bottom of the keypad, opposite of the 0 or near the 0, and that is what you use for negative numbers. If you're putting a negative number into a calculation, you need to use the negative sign at the bottom of the number pad. The way you put that in will change the outcome of the formulas that you put into the calculator. So let's practice doing negative signs. For example, key in a -8 using the negative sign at the bottom of the keypad, not the subtraction sign, -8 plus 4, and hit enter. If you've done it correctly, it should show -4 on your calculator for the answer. Next, try a few other small calculations like -6 plus 2, -2 times 5. Take note, is the input still showing on the screen after you hit enter? And can you scroll back using the arrow keys? And those answers will, again, depend on what type of calculator you're using, if you have the 30 or the 36. Next, find the exponent key on your calculator. On some calculators, that's represented by a caret, this arrow that's pointing up. On some calculators, there will be a key that has X with a box up above it, or an X squared key, which looks like this. Note that the X squared key can only be used for squaring, like 2 squared would equal 4. This is what you will use to calculate exponents on your calculator. Note that any calculations with negative signs that have an exponent should be put into parentheses. So instead of just typing out a -3 squared, make sure to put that -3 in parentheses and then hit the squared key. You should end up getting 9. If you try to square a negative number, if for example I were to say -3 squared and it came out as -9, I've done something wrong. Make sure that you double check your parentheses on negative signs. Take a moment to plug these exponents into your calculator and ensure that you've gotten the correct answers. 3 squared should give you 9. Negative 6 cubed should give you negative 216. And negative 10 to the 6th should give you 1 million, or 1.0 times 10 to the 6th if it's coming out in scientific notation. Next, look for the number pad and the mathematical operations square root, which kind of looks like a check mark, pi, which looks like this, log, and natural log, which is denoted with an ln. To perform the calculations, make the keystrokes and hit enter. For example, try to put in square root of 64. If you've done it correctly, it should give you 8 as your answer. There are other small calculations we can try. For example, 3 pi, you just put it in like that, should come out as 9.424 and so on. The log of 10 should give you 1. The natural log of 24 should give you 3.178. Some calculators have a secondary function written in a different color above the key. So the key itself may give you a square root function, but right above that it may have a cube root function. The additional functions are not used as commonly as the primary functions, but you may need them occasionally. To get to the secondary function, you should be able to locate a second, a shift, or an alpha key on your calculator's keypad. If you can't locate the key, look at the manual for your calculator or come in and ask us for help. We're happy to help you walk through this in person as well. Try using the second, shift, or alpha key to perform some simple calculations. Find the key that gives you e to the power of, put in e to the power of 6, and you should get 403.42. The tangent of negative 1 should give you 45, and the cube root of 8 should be 2. Double check your answers when keying in these calculations. If you did not get the same answers and you need help, please contact us so we can help you walk through how to fix that. Next, let's consider some mathematical concepts you may need to understand to use your calculator effectively. The first we'll want to consider is scientific notation. When a number is too big or too small for your calculator to display effectively, the calculator will use scientific notation. It'll represent the number as some number between 1 and 10 times a power of 10. For example, this particular number would become 3.2 times 10 to the 12th. Your calculator might use the symbol e or exponent to mean 10 to the power of. So 3.2 times 10 to the 12th can also be displayed as 3.2 E12. When entering scientific notation, you will be using this button, x times 10 to the n. For example, if you wanted to put 5.41 times 10 to the third in your calculator, you would type 5.41 and then select the x to the power of 10 button and hit 3 to enter the exponent of 3. Your screen would end up saying 5.41 times 10 to the third power. To write numbers in scientific notation, you move the decimal place until you have a whole number on one side, just one whole number, on the left side of your decimal point. If I wanted to write 3,200 in scientific notation, I would move the decimal point 3 places to the left. It starts here. I'd go 1, 2, 3. I had to move it 3 places, so my exponent would be 3. And the start of the scientific notation number would be 3.2. If I wanted to write a larger number in scientific notation, such as 985,625, I would end up moving the decimal point 5 places to the left, 1, 2, 3, 4, 5, to get to right between the first and second numbers. Since I had to move it 5 places, my exponent will be 5, giving me 9.85625 times 10 to the 5th power. Take a moment to practice expressing each of these numbers in scientific notation. Feel free to pause the video and work it out, and then come back to see if your answers are correct. For 625, you should have written out 6.25 times 10 to the second. We move that decimal point twice. For 25, you should have 2.5 times 10 to the first. We move that decimal point once. And for 62,503, you should have 6.2503 times 10 to the fourth, because we moved it 1, 2, 3, 4 times. The inverse can also be true. You may sometimes need to write scientific notation with negative exponents. All the negative exponent means is that instead of moving the decimal point to the left, you are moving it to the right. So for example, if I want to write 0.0061 in scientific notation, again, I'm taking that decimal point and moving it 1, 2, 3 places until I have a number, at least one number, in front of my decimal point. That gives me a 6.1. My exponent will be -3 because I moved it to the right 1, 2, 3 times. And I should end up with 6.1 times 10 to the -3rd power. You can do this with longer numbers as well. For example, with 0.0000285, I'll end up moving that decimal point 1, 2, 3, 4, 5, 6 places to the right. My exponent, therefore, would be -6. And it should end up giving me 2.85 times 10 to the -6th power. Again, remember that if you are moving the decimal point to the right, it is a negative exponent. If the decimal point is moving to the left, it is a positive exponent. That's easy to mix up, but it is important to keep straight. Take a moment, pause this video, and practice expressing each of these numbers in scientific notation. Then come back to see how you did. For the first one, 0.052, you should have 5.2 times 10 to the -2nd power. For 0.00492, you should have 4.92 times 10 to the -3rd power. And for 0.0000312, you should have 3.12 times 10 to the -6th power. When performing a calculation with scientific notation, you do need to make sure to use parentheses around the scientific notation value. For example, if you are dividing 1.0 times 10 to the 3rd by 5.0 times 10 to the -2nd, you should write it out like this. Put parentheses around the 1.0 times 10 to the 3rd, and then put parentheses around 5.0 times 10 to the -2nd. When in doubt, put parentheses around it. This should, if you enter it correctly, give you the answer of 2.0 times 10 to the 4th, or 20,000. Take a moment and try entering these practice problems into your calculator, ensuring that you use the parentheses around each scientific notation segment. Pause the video, and when you come back, check your answers. Now that you've done that, let's take a look at the answers. The first one should give you 1.004 times 10 to the -5th. The second should give you 6.274 times 10 to the 23rd. And the third one should give you 8.659 times 10 to the 4th. Next, let's take a moment to consider fractions and how they work in your calculator. The fraction bar represents division, and you need to make sure to put parentheses around the numerator and the denominator. For example, if we need to calculate 1 divided by 2 plus 3, we would put that into the calculator, and if you use the rule above with parentheses, it should simplify to 1/5 or 0.2. But if I put in 1 divided by 2 plus 3, the calculator gives back 3.5, which is definitely not the same answer as 1/5. Why is that? The calculator cannot see the fraction bar. We need to use parentheses to tell the calculator what order to do things in. So for this example, we would need to put in 1 divided by, in parentheses, 2 plus 3. to return the correct answer 0.2. Don't forget about that rule in more complicated calculations either. When you're writing out a longer formula, you would want to make sure to put the entire fraction into parentheses as well as the numerator and denominator. Next, we'll consider the order of operations. Some calculators have algebraic logic and some do not. If your calculator is a scientific calculator, it will follow the order of operations, which you may have learned somewhere along the way. It goes parentheses, exponents, multiplication, division, and addition, subtraction. Do be aware that this means that multiplication and division should be performed from left to right, regardless of what order they come in. And the same should be done with addition and subtraction. To remember the order of operations, you can use the abbreviation PEMDAS or the acrostic, "Please excuse my dear Aunt Sally." So let's take a moment and practice. Remember to solve all the problems in parentheses first, then look at your exponents, then multiply and divide from left to right, then add and subtract from left to right. So for the problem 21 divided by 3 plus 3 times 9 plus 5, what should the answer be? Take a moment to work it out, pause the video, and then come back to see the correct answer. Let's walk through the steps of this. First, you should have worked out what was in the parentheses, 3 times 9, which is equal to 27. So we'll put the 27 in the place the 3 times 9 was. Next, we need to do 21 divided by 3, which gives us 7. We replace 21 divided by 3 with a 7. After that, we move on to 27 times 9, which is 243. So we'll replace 27 times 9 with 243. From here, we just have addition left. So we start again from the left. 7 plus 243 is 250. And 250 plus 5 is 255, which should be your final answer. And if you put it into your calculator correctly, that should be the answer you have as well. For your next practice problem, try 28 divided by 4 plus 3 plus 10 minus 8 times 5. Pause the video, take a moment to work it out, and then come back to see if your answer is correct. If you did this correctly, you would have started by dividing 28 by 4, as it is in parentheses, and would replace it with a 7. Then you'd move on to the next set of parentheses with 10 minus 8, which equals 2. You would go on to 2 times 5 for multiplication, which would give you a 10. From there, you've got addition to deal with. 7 plus 3 is 10. You add that to your other 10, and you should have come out with the answer of 20. And that should be what's on your calculator as well. Next, let's take a moment to consider how we can manipulate an equation. In algebraic thinking, you will often need to isolate the variable that needs solving. This can also help us to keep track of the units and prevent mathematical mistakes. The first thing we want to do is a practice problem. So in this equation, we want to solve for the speed of light, which is c, in this equation. We'd want to take a few steps to solve for c, and we start by isolating the variable c. So to solve for c, we need to isolate c by moving everything over to the other side of the equation. C is already on the right. We want to move everything around the c to the left. So first we want to divide by mass, which is m, so we can isolate c on the right-hand side. But remember that what you do to one side of an equation, you have to do to the other. So we have to divide energy, E, by mass, m, as well. So you should have gone from this to this. E over m equals c squared. So now c squared is on the right-hand side by itself, but we want just c, not c squared. To get rid of the square, we need to take the square root of c squared. And again, what we do to one side, we have to do to the other. So we'll have to take the square root of the left-hand side of this problem as well. And we should, if we've done that correctly, end up with the square root of e over m equals c. And now c is by itself, and we can solve this problem as it is written. Let's try another practice problem. The formula for the area of a triangle is a equals 1/2 b times h, where a equals area, b equals the length of the base, and h equals the height of the triangle. In this problem, we want to solve for height. We want h. So we will need to isolate h from the rest of the equation. Generally speaking, it's easiest to save your fractions for the end of the problem. So let's start isolating h by dividing away b, or the base. So we would take and divide the entire right side of this equation by b. But remember, what we do to one side, we have to do to the other side. The b's on the right-hand side will cancel out, and we should have a over b equals 1/2 of h, like so. But now we need to deal with this fraction. So we have a over b equals 1/2 h. To get rid of the fraction, we should multiply it by its denominator. 1/2 has a denominator of 2, so we'll multiply 1/2 of h by 2 and place the 2 over 1. That means that the 2 here and the 2 here will cancel out, leaving us with 1h. But we also have to do this to the other side. We have to multiply 2 over 1 by the left-hand side also, which will give us 2a over 1b, or just b, equals 1h. And in so doing, we've isolated the h variable, and it's possible for us to solve the equation for height. The third practice problem here, if we want to practice rearranging, manipulating one more equation. The formula for the ideal gas law for chemistry is PV equals nRT. We want to solve for moles, or N, the amount of the substance in this equation. To do that, remember to isolate from the rest of the variables. If we have nRT all together, that means they are being multiplied. So to isolate N, we'll need to divide by RT. Remember to do the same thing to the other. So we have nRT divided by RT, and then we add PV over RT. The RT with the N will both cancel out, leaving us with PV over RT equals N. And that will give us everything we need to solve the problem. If you're in Math 171 or a lower course than that, this should be everything you need to know. If you have questions or concerns or things that you want to understand better, feel free to contact the Tutoring Center and we will be more than happy to assist you with those specific questions. If you are in Math 172, however, there is one more section of this workshop that you will want to go through before you finish. So take a moment to consider the next section of this presentation. In Math 172, there is one more calculator skill you'll want to familiarize yourself with, and that is the ability to convert between degrees and radians. First off, what are degrees and radians? Well, they're the most used measuring units that we calculate angles by. A degree is an angle made by one part of 360 equally divided parts of a circle at the center with a radius of r. A radian, on the other hand, is the angle made at the circle's center by an arc of length equivalent to its radius. To convert an angle from degrees to radians, you can use the following formula. Radians equals degrees times pi divided by 180. Here, this symbol, pi, is a mathematical constant that is approximately equal to 3.14159. To convert an angle from degrees to radians, you multiply the angle in degrees by pi over 180. For example, 30 degrees equals so many radians over 30 times pi divided by 180. The first thing you would do is to place 30 over 1 to make it into a fraction. When dealing with fractions, we try to simplify the numerators and denominators as much as possible. In this case, we can simplify 180 degrees by dividing it by 30, which gives us 6. Similarly, we can simplify 30 degrees by dividing it by itself, which gives us 1. So the fraction can be simplified to 1/6. After simplifying the numerator and denominators, we can now multiply the numerators with each other and the denominators with each other. It's a common step when solving equations or simplifying fractions. And we are left with the answer pi over 6 as our final answer. So let's take a moment to do a few practice problems. Pause this video and practice converting each degree measurement into radians. Then come back. For problem 1, you should have gotten the answer -5 pi divided by 6. For problem 2, you should have gotten 23 pi divided by 12. And for number 3, you should have 37 pi divided by 12. So that's how you convert degrees to radians. Let's go in the opposite direction. If we want to convert from radians to degrees, we can use the following formula. Radians equals radians times 180 divided by pi. And again, remember that pi is a mathematical constant. To convert an angle from degrees to radians, you just multiply the angle in degrees by 180 over pi. For example, let's take the answer we just got. Pi divided by 6 equals however many degrees divided by pi divided by 6 times 180 divided by pi. Again, when we deal with fractions, we want to simplify numerators and denominators as much as we can. We can simplify 180 by dividing it by 6, which will give us 30 degrees on the top. And we simplify 6 by dividing it by itself, which gives us 1. So our fraction can be simplified to just 30 degrees. After simplifying the numerator and denominators, we can now multiply the numerators with each other and the denominators with each other, which is what we typically do when solving equations or simplifying fractions. And we should be left with the answer 30 degrees. So we took our first practice problem and reversed it, and we should end up with the same answer we started with. I'll give you some time to practice these on your own. Pause this video, take a moment, and convert these radian measures into degrees. When you finish, you should have 10 degrees as the answer for 1. Number 2 should be -660 degrees. And number 3 should be 945 degrees. I hope this workshop has been helpful and beneficial to you in learning how to use your calculator and do some of these more basic math problems and applications. If you have questions or need further assistance, feel free to contact Jaguar Tutoring here in the library at JCC, and we are more than happy to assist you in solving those problems and working through any issues you may be having with your calculator.